Howdy YouTube, Matt back with part 2 of the USB Stompbox for Garageband. When we last left our hero, it was black. This is what happens when you clean out the spray paint cabinet. It also now has a hole in the end, which has been plugged up with just a little USB extension cable that comes in a mounting flange. This is going to give me a way to hook this up to the external world and unhook it without having to really get at the guts. This thing just ends in a little USB pigtail in here. Switch plate, you've seen that. And then here's going to be the guts of it. I will zoom in on this and go through it, don't worry. This is what's called a Teensy. It is a little variant on a very popular microcontroller called an Arduino. And this particular one is nice because it is really set up specifically to look to whatever computer you plug it into via this USB port right here, like a keyboard or a mouse or a joystick or something else that uses what in computer parlance is called the generic HID, Human Interface Device driver. In plain English, what that means is you can plug this into your computer and it looks like a peripheral that it already knows about and the computer already has the software to talk to. You don't have to write anything funky or install anything on your computer to make stuff that comes out of this controller show up inside your computer and inside the apps. So I learned from the welder videos that some of you guys actually want to do this stuff, and therefore you want to know about all of the parts and where they come from, how you can get them and such things. So let's head on over to the computer and I will show you where I got the Teensy, where I got the capacitors, resistors, all that other fun, happy stuff. The bulk of the pieces and parts for this project came from pedalpartsplus.com. There are 100,000 places online to get basic electronic components. So the resistors, the capacitors, the wire wrap stuff, all of that kind of junk, you can get pretty much anywhere. But there's a couple of things I like about this particular supply place. First and foremost, for this project, they have switches. Exactly the right kind of switches. These are direct replacements for the switches that are in commercial guitar pedals. For my project, I'm using these. They're single pole, single throw, normally open, momentary switches. The LEDs came from here as well. They're 5mm and they happen to be blue. You could get whatever color you want. They happen to have very nice chrome bezels for the LEDs as well. I picked these aluminum ones because they're frankly a little bit cheaper. On the resistor front, 8-watt resistors are fine, and exactly what value you want is going to depend a little bit on what LED you pick. I ended up with 2.2K resistors. The microcontroller, which we'll look at here in a second, will drive anything from a 470 ohm resistor up to a 10K resistor. Just depends on how bright you want the LED to be. Then on the capacitor front, ceramic capacitors are fine for this and yield 0.01 microfarad, 16 cents a piece. Can't beat it. Is perfect. So that leaves us with the microcontroller, which is available from a website and a company called PJRC. We are using the Teensy version 2.0 in this case, for no reason other than it's cheap. It's real cheap. 19 bucks if you get the one with the pins. It's actually available without the header pins. If you want it that way for other projects, it'll save you $3. The PJRC website also contains all the instructions you need to get your development environment set up to work with a Teensy. In my opinion, the easiest way to work with this thing is to just set yourself up with a regular Arduino development environment and then get this little add-on called Teensy Duino. The steps are here on the PJRC website, including links to where to get the Arduino software, how to install the whole thing and get yourself up and running. Once you go through the instructions and set up the Arduino development environment and then add the Teensy Duino plugin, you're all set to start writing the software for this little project. Unfortunately, the software is dirt simple. In fact, most of the program that ends up running on the Teensy is created by configuration of the development environment rather than us having to write code. The two things we want to look at are up here on the Tools menu. The first one is this board option. You need to tell the development environment what kind of a board you're going to be targeting your code to. We're using a Teensy 2.0. Note that none of these Teensy options exist natively in the Arduino IDE. This is what that Teensy Duino plugin added for us. The other thing we need to set is the USB type. And this is the magic of the Teensy itself. It has baked into its USB circuitry the ability to model all kinds of different, very common USB devices. In our case, we want the device to show up to the computer as a keyboard, so we'll pick keyboard, mouse, and joystick. We just created what on a standard Arduino would have been a fairly big pile of code to do all the USB interfacing for a keyboard, but on the Teensy, it's one click of the mouse. Most of this program is definitions and then 5 iterations of the same thing because we have 5 switches. So going through it, the first thing we do is we define which pins on the Teensy are being used for the switches. In my case, I went up the one side of the device and I have them. It's in order when you look at the chip. It looks backwards when you're looking at the program like this, but this is moving away from the USB port. So switch 1 is actually hooked up to pin 15 on the Teensy, down through switch 5 is hooked up to pin 11. My LEDs run down the other side of the Teensy, starting with number 1 at pin 6 and then going up to LED 5 at pin 10. And then I have 5 Boolean status variables. What these are used for is to keep track of what was the status of the switch the last time I ran through the code. Under normal circumstances, because what the switch is doing is grounding the input on the Teensy, when the program scans that input, the switch isn't usually pressed, and so it normally reads a value of high or 5 volts or charged or however you want to think of it. So I initialized my status variables to high because that's what they should find on the first run of the program. There's a setup routine that runs just once at the very beginning when you power on the Teensy, and all I'm doing here is defining my 5 inputs for the switches as inputs, and I'm using one of the other features of the Teensy, which is a built-in pull-up resistor. Saved me having to put one externally. They have this baked into the chip, and if you configure the input with this input underscore pull-up flag, then it activates that built-in resistor. So your inputs will be tied via a resistor to the 5-volt power without you having to hook up anything yourself. The LED pins are going to be outputs. And just for good measure, I did a write to all of the LEDs to turn them off. The Teensy defaults to low output pins, so this isn't strictly speaking necessary, but I did it anyway. Here's the main loop for the program. This is the code that the Teensy will execute over and over as long as it's powered up. I have one temporary variable declared in here just to keep the code readable. There's the same routine for each of the 5 switches. We'll go through switch number 1 first to show you how it works, and then I'll just give you a quick tour to see that all the other 5 switches are the same. These lines that start with 2 slashes and are light gray are comments. They don't actually do anything for the code. Our first step is to go and read the value of the switch input. Remember that we have a pull-up resistor inside the Teensy pulling this circuit to a value of high unless the switch is depressed, which will ground the input and give us a value of low. So that's the first thing we check for. We only have anything to do if we got a low, meaning that the switch was depressed. However, we don't want to send the keyboard command or change the LED status every single time we scan the switch as low. The Teensy is pretty fast. In fact, it's doing this every 5 milliseconds. So it's highly likely that your foot will be on the switch for more than one scan of the code. Therefore, we need to keep track of the status of this. We need to check and see if the last time we scanned it was low or not. We're only going to take the keyboard action and change the LED on that first change from high to low. If we're high or if we've stayed low for multiple scans, there's still nothing to do. If we make it this far, then we in fact are on that first scan after transitioning from switch not pressed to switch pressed. This is where we need to do what we need to do. We're going to send the keyboard command, which for the Teensy is a very simple keyword of keyboard.print, and in my case, I'm sending a 1. And the last step in our do something routine here is to toggle the status of the LED. If it's on, I want it off. If it's off, I want it on. The easy way to do that is to use the exclamation point, which in Arduino command language and most of the C variance means not. So this statement reads, write to LED 1 the opposite of whatever you read from LED 1. Arduinos are kind of nice in that you can read the current value of an output pin. One last housekeeping item, since we're checking to see whether the transition has occurred from high to low, we need to maintain essentially the status from the last scan. That's what this step does. Regardless of whether we took any action or not up here in the if statements, the status variable will be updated to reflect whatever we read from the switch on this particular iteration of the code. That way, the next time we come through here, we have what happened last time available to us. It's exactly the same code for the rest of the switches. Here's switch 2, switch 3, etc., switch 4, and switch 5. There's only one more command in the program. That's a short 5 millisecond delay. Even with the capacitor across the switch, it's possible to get what's known as bounce, where the switch actually transitions from high to low or low to high a couple of times as you're pushing it or letting it up. The Teensy scans fast enough to pick up these transitions. The capacitor smooths most of them out, but the 5 millisecond delay acts as a digital version of the debounce. Keeps the Teensy from checking the switch so often that it's likely to hit one of these bounce conditions. All right, let's walk through how the circuitry is hooked up to this Teensy. First things first is to know which pins we're using. These guys right here, 15 through 11, are our inputs, our switch pins, and these over here, 6 through 10, are the ones that we're using as the LED outputs. Because we used the internal pull-up command when we configured the inputs, we essentially have a power resistor that pulls each one of these inputs up to 5 volts. However, you don't really see that in the circuit because it's inside the Teensy. We'll concentrate just on the one pin at this point. What we've done is we've added a capacitor that goes to ground. Now, of course, the capacitor is an open circuit to DC voltage. So under normal circumstances, this input is going to sit at the plus 5 volt high. But the other thing that we put in here is we put in our switch. The normally open switch has no impact on the circuit, but when you close it, you make this connection. You essentially short out the capacitor and you bring this input down to ground. Lather, rinse, repeat 5 times. We have the exact same circuit on 15, 14, 13, 12, and 11 for the 5 switches. The LED outputs are even simpler. We have yet another resistor. In my case, I picked 2.2 k ohms. Then we have an LED, which also runs off to ground. That's it. Pathetic drawing notwithstanding, that's the entirety of the circuit. All right, now that we've seen how this little circuit works, we have to figure out how to get it mounted in the Stompbox. Now, unfortunately, the breadboard won't fit in there. Maybe that's not unfortunate. A breadboard is no way to deploy a circuit on any sort of a permanent basis. I think especially in duty, where it's going to get stepped on and banged around on the floor, it's just not solid enough. So I need to come up with some sort of an actual circuit board for this thing, and I could go to the bother of actually etching a printed circuit board, but I just don't have the materials or frankly feel like it. So I'm going to use this thing. This is a pin board, which I got at Radio Shack before they went out of business. What this allows you to do is put components through the board and then solder them so that they won't come out. These little copper pads aren't connected to each other in any way, shape, or form. They only serve as an anchor to keep the components on the board. In order to actually make connections between things, we're going to use a technique called wire wrap. It requires this little tool. It's probably one of the other things that Radio Shack still has laying around because nobody knows what they are anymore. And what this tool does is it takes this little fine wire and it twists it, little curly-Q pigtails around the leads of your components after they're in place on this board. You make your connections point to point with little short pieces of wire. I'll demonstrate that once we get some stuff on here. But first things first, I got to get these components organized onto this board somehow. All right, I've soldered 4 of the pins on the Teensy. That's more than enough to hold it in place on this board, and it saves me from running the risk of putting too much heat into the microcontroller and maybe frying the thing. The rest of these components are not nearly so delicate, but I'm going to leave the soldering iron set on 350 degrees C. Okay, the wire wrapping process is really very simple. You start with the end of your wire and you strip off a couple of inches, maybe 1.5, 2, something like that. And the wire wrap tool, and you can't see this I'm sure, but there are actually 2 holes in the end of this thing. One is offset from the side and lets the wire go through the tool and up into this slot. The other is right dead center. And that's the one that you slip over the lead of the component. You hold the wire down and twist. Twist the tool until the end of the wire comes out and you're left with it wrapped tightly around the leg of the component. I'll cut it off for the other end. Grab the stripping tool. Load up the wrap. Find the second leg on our Teensy and give her a spin. And there you go. We now have the first output of the Teensy hooked up to one leg of the first resistor, second leg of the Teensy hooked up to the second leg. Once these are all wrapped, you can come back and hit them with a little bit of solder if you want to, but it is surprisingly unnecessary. These wraps are much, much stronger than you would imagine. Okay, well, after a couple of dozen pieces of wire from here to there and everywhere, we have one completed wire wrapped circuit. These little lightweight white jobs are the power supply that will run off to the 5 LEDs. These heavier red wires are the ones that are going to run off to the switches. And then there's one bare copper wire back here that is the common ground for both. Now for the fun part. I have to figure out how to get this whole mess in the box. The wiring for the first 2 switches goes straight from the board to the switches and to the LEDs, no big deal. The other 3 have to pass through this little hole I made in the center of the case. But what I'm going to do is I'm going to start by hooking up just the first 2, and then I'm going to test it. I'm going to hook it up to the computer and see if I'm getting the right characters and the right numbers and the LEDs come on, all that fun, happy stuff, before I snake all the rest of that wiring through the holes and connect them. Okay, 2 of these things are hooked up, and I've got the whole thing kind of folded over here the way it's going to go in the box. I'm going to plug in ye old USB cable to power it up, and then what you're seeing in the corner of the screen here is the input that the computer sees coming from the USB keyboard. I have it just going into Microsoft OneNote. But the moment of truth, if I push this switch, I should get the LED light to come on, and I should get a 5, because this is switch number 5, and currently that's the way I have the Teensy set up to send a number 5 when I push that switch, and the LED stays on. And if I push it again, I get a second 5, and the LED goes off. Perfect. That's exactly what I want. Let's come down here and try the other switch. And I get my 4 and another 4. Awesome. Now I just got to hook up the other 3. Well, here she is all wired up, wire tied into some nice, neat little bundles. Basically, here's the bare copper wire that is the ground. Ultimately, the switch and the LED are both connected to that. The LED, I just took a short piece of this wire wrap material, wound it around the leg, wound it around the copper bus, and I did tack that down with solder. The other lead to the LED comes straight off of the circuit board down here. Likewise, the switches come off of the circuit board over here, and then obviously the other side is the ground bus. I made a design change. I originally had a hole in the middle of this support to run the wires through. way, way, way too painful trying to get the thing hooked up with all the wires going through the hole. So I have instead opted for a slot, which was easy enough to cut. All that remains now is to hook the little USB dongle, extension cable, whatever, up to here. Flip this bad boy over. Tuck the circuit board itself down in the slot between the switches. Curse at most of the wires that are in the way. Well, there she blows, YouTube. There's our creation. 5-switch pedal board sitting on the floor all painted up. Ain't it purty? And the rest of the rig looks something like this. The Strat on the right is by no means a good one. It's part of their Modern Player series. They're made in China, and they're about $300 new and less than that used, which is how I got mine. And there sitting on the piano bench is the ever popular MacBook Air running Garageband. I'm going to switch over to a screenshot on the computer and show you how we translate the 1, 2, 3, 4, 5 keyboard signals that come from the pedal board into something useful in the Garageband application. This is the pedal board window in the Garageband application. As you can see over here on the right, Garageband has quite the collection of effects pedals that it can simulate. You can load them all up here, put them in any order you want. The problem is there's no way to control these things except by bringing your mouse over here and clicking on this button. There's no built-in keyboard shortcut that you can map to these buttons. Enter an application called Quick Keys. Quick Keys is exactly what we need to fill in this gap. It allows you to define custom keyboard shortcuts. In my case, I have 3 of them, toggle pedal 1, 2, and 3. And if you dig into here, you find out that all this is a definition that says, okay, if you're in GarageBand anywhere and you get the hotkey number 1, which is what our first switch generates, then go and click the mouse at this particular location on the display. Well, that particular location on the display happens to be right here on the button that turns pedal number 1 on and off. Likewise for the shortcuts for 2 and 3. So now I'll just do it with the keyboard. You see if I press 1, the mouse pops over there, hits the flanger, turns it on and off. 2 does the phase tripler, and 3 does the octave pedal. Okay, well, moment of truth time. Let's see if I can actually put all of this together. Note of warning, if you thought my welding was bad, wait till you see the guitar playing. This is a demonstration of the pedal board, not of any sort of guitar skill. You've been warned. Well, I'm going to call that a success. My definition of success here is that those switches that are on the floor make changes in that application running on that Mac. As for whether I'm having any success with this thing, that's a story for another day. For those of you who are going to take the time to comment and let me know that I stink, save your precious moments. I'm already well aware of where I stand with this thing. But it was fun nonetheless. And I have to tell you that realistically, I've got less than $50 in this project, and there is one and only one thing that I could find that you could buy to do this same thing, and it's a couple of $100. So if you fool around with GarageBand, this is well worth your time to do if you need the functionality. Is GarageBand and a DIY switchboard going to replace a pedal board full of real effects? Yeah, absolutely not. The effects in GarageBand are just sort of okay. They're fine for me just trying to learn. But if you were good enough to be invited to play a concert somewhere, this doesn't sound good enough,
and this whole setup is probably too brittle to use in a production capacity. But for me here, just fooling around, it works great. As usual, questions, comments, feel free to leave them down below. The video is already a half an hour long, so I couldn't very well put any more in here, but I'm sure there's a lot of detail that got skipped in the process. Thank you very much for sticking with me to the end of this. Till next time, stay safe, YouTube.